Good morning.
Good morning, students. Welcome back to science class on the chapter force. Okay. In the previous class, we had discussed about the momentum, right? Already you know what is momentum. Momentum is nothing but it is a quantity of motion, or it is a multiple product of mass into velocity. Okay. Then we measure momentum in the essence of momentum is kg meter per second. Okay. So we have formula P is equals to if one object it moves with the velocity and its mass m, so then it will have momentum that is P is equals to mass into velocity. So when you multiply its mass and velocity, you will get the momentum of that object. Means while moving, how much it will carry? Okay, how much quantity it will carry? So you will get that one. Okay. So today we'll discuss the rate of change of momentum. You know, see one object is moving. Say for example, say one object its mass is 5 kg and it is moving with the 2 meter per second. Then you will apply force. What will happen? Its velocity changes to say 10 meter. Sorry, mass remains the same, right? There is no change in mass of an object. Its velocity changes to 5 meter per second. Okay, 5 meter per second. So why here the velocity changed? Why? Because you have applied force. So its velocity changed from 2 to 5 meter per second. Okay. Next. So see, before the application of force, I calculate its momentum. That is if equal to m into v. So 5 into 2. So that is a 10 kg. 10 kg meter per second. If you calculate here, m into v mass is 5 kg into 5. So then you will get 25 kg meter per second. See, just observe here. Okay, this is 10. Okay, see here. Suppose you know before applying a force, if you stand here, okay, this object will collide with you, so you will get a little bit hurt. Why? Because it collide with you. And see now in the case after the application, you will stand here. Okay, so here also you will get a little bit hurt because it collides with you. So here and here, in which position you will get more hurt? So before the application of force or after the application of force? Okay, see first you will stand here before the application of force. Just imagine it will collide with you, so it will little bit get hurt. And here also you will stand here, and it will also here also you will get little bit hurt. But in which case more? Okay, at this case, why? Because here it is moving with 2 meter per second, but here it is moving with 5 meter per second. So in this case, its momentum is more. So that's why you will get more hard. Okay, so because of the application of force, we can change the momentum of an object. Okay, we can change the momentum of an object. You know, see if you want to bring objects from rest to motion, motion to rest, or if you want to change the velocity, or if you want to change the direction of an object, so we will use the force. So without force, we can't do, we can't change its direction or whatever. Okay, but now we can say that because of the force, we can change the momentum of an object. Okay, because of force, we can change the momentum of an object. Okay, now see here. Now I will call this is initial momentum here. Okay, no, before that, you know, so just imagine one car is standing. So now you want to start that car, so it won't start. Okay, just imagine that itself it doesn't work. Okay, then what you will do? So you will push, right? You'll push that car. So initially you will push that car slowly. No, it won't start suddenly. Okay, it won't, while pushing it won't start suddenly. After covering say how much 20 to 25 meter, at that time it will start. Why? Because see, just imagine one car is there, 4 members are pushing that car. 4 members are pushing. So initially it won't start. Why? Because it is the starting time, right? Because they will push that car slowly they will increase their velocity. After covering 20 to 25 meter, do you think that its velocity, which is equal to at the starting time? No, right? At the starting time, its velocity is slow. Because why? Because they just started that pushing. Okay, after covering 20 to 25 meter, the velocity of that car is more. Okay, so now I will ask, in the after covering 25 meter, at that position or starting position, in which position the momentum of that car is more? So clearly we can say that after covering a 20 to 25 meter, because at that position the car is moving with some high velocity compared to starting position, because starting it is very less its velocity, correct? So now here clearly we can say that starting is less momentum, at the after covering a distance of 20 to 25 meter it has more momentum. Okay, so now here that momentum changed from starting to that after covering a 25 meter. Okay, that momentum changed in sometime maybe say 5 seconds or 10 seconds. Clear? Okay, now see here, now see this example. Now here, this I will call, this is the initial momentum. What is that? Initial momentum. Initial momentum, and this is final momentum. Okay, now see here, clearly we can say that momentum changed here. Okay, momentum changed from 10 to 25. Here the momentum changed from 10 to 25. Okay, to change from 10 to 25 it will take some time, right? Maybe it is 1 second or 2 second or 3 second, whatever it is, but it will take some time, right? So you have studied what is that, a is equals to v minus u divided by t. What it represents? Okay, so a is equals to v minus u, a is equals to v minus u divided by t. So here acceleration is equals to change in velocity in a given time, which means here one object changes its velocity in some time. So we call it as acceleration. What is acceleration? In a given time its velocity changes. Okay, so we will call that it as rate of change of velocity or change in velocity in a given time. So here also same. Here also the momentum is changing. The momentum is changing from 10 to 25. Okay, in time, right? Maybe it will take 1 second, 2 seconds, whatever it is, but it will take some time. Maybe less than 1 second, but it will take some time. Okay, see here momentum changed from 10 to 25. Okay, so now here to calculate acceleration, here we have used v minus u divided by t, that is final velocity minus initial velocity divided by time taken. Now see here, here momentum is changed. Why? That is because of force. Okay, so now clearly I can say here the momentum is changed in a given time, that is because of the application of force. Clear? So we can change the momentum in a time, that is because of application of force. We can represent this overall thing mathematically like this. That is F is directly proportional to, see a change in momentum, change in momentum, change in momentum divided by time taken. Clear? See, F is directly proportional. Directly, what it represents, this symbol, that is a directly proportional. What it represents or what it says here, the momentum is changed in a given time. That is because of application of force. Okay, so you can change the momentum of an object in a given time. That is because of the application of force. So now on this basis, now we can state the second law of motion. Okay, so what is the second law of motion? See, just to understand the concept, the momentum changes in a given time, that is because of force, right? So we can clearly say that the rate of change of momentum, is directly proportional to the applied force in the direction of the application of force. So got it? So what is the second statement, the law of motion, or Newton's law of motion? This the rate of change of momentum of a body is directly proportional to the force. Okay, acting on it takes place in the direction of the force. That is second. Okay, see here. What is second statement? Of a body is directly proportional to the force. Okay, in the application of the force. So this is the second law of motion. See, I have used the rate of change of. Why? Because something is changes in a given time. We can call it as the rate of change of, right? You know, acceleration v equal to v minus u, a is equals to v minus u divided by t. So we can call it as one. We can define acceleration or change in velocity in a given time, or the rate of change of velocity. Here velocity changes in a time, so that's why we call it as rate of change of velocity. Instead of velocity here, what changes here? Here momentum changes. So that's why their rate of change of, but here their rate of change of velocity, and here rate of change of momentum. Okay, rate of change of momentum. So clear? So the rate of change of momentum of a body is directly proportional to the applied force. Okay, and it expresses in the direction of the force. For example, I am applying a force in this direction. I am applying a force in this direction, then its momentum changes in this direction only. So clear, right? The second statement law of motion. So what it says, the rate of change of momentum is directly proportional to the applied force, and it takes in the direction of the force, in the direction of the application of the force. Okay, so here see this understood this example. Here the momentum changed in a given time. Clear? Okay, see here change in velocity we have represented mathematically, that is final velocity minus initial velocity. Now how to represent this change in momentum mathematically? Okay, how to write that change in momentum mathematically? Okay, yes sir. In the comment box. Now see here, actual acceleration means what? Acceleration equal to change in velocity, change in velocity by time taken, right? So here we have written what? Change in velocity as v minus u, that is final velocity minus initial velocity. Now how to write mathematically this is a change in momentum, change in velocity. See here we have written that is final velocity minus initial velocity. Now how to write that change in momentum? Yes, so put it in the comment box first. I am waiting for your answer. How to write mathematically this change in momentum? Quick, I'm waiting for your answer. Here change in velocity means final velocity minus initial velocity. Okay, but here how to write that change in momentum? First, yes, here you have written m into v minus u divided by t. No, that is m is okay. First, right? What is that m into? What is the meaning of that m into v minus u? What is the meaning of m into v minus u? Yes, first, how to represent that mathematics, that change in momentum? Because already we have studied, right? Change in velocity we can write mathematically, that as with final velocity minus initial velocity. Now here how to write that change in momentum? First, quick. That is v minus m divided by t. So what is that? What is the meaning? V minus m divided by t. V minus m divided by t. No. Yes. What about others? Okay. See here. You know, change in velocity. We can write this as mathematical as final velocity minus initial velocity. That is v minus u. Now, how to write this? A change in momentum. Change in velocity equal to final velocity minus initial velocity. Then change in momentum. So change in moment. How to write that change in momentum? First, See the same concept what we are studying in the acceleration. Their velocity here, m means what? Here you have written m into v minus u. What is the meaning? Velocity, that is final velocity minus initial velocity, and here change in momentum, which is equal to final momentum minus initial momentum. That's it, very simple one, right? Okay. See here. Now here we have considered one object, right? Initially it was moving with the 2 meter per second. Now I will take its velocity as here, and its velocity as initial velocity u equal to 2 meter per second, and here its velocity as 5 meter per second. Okay. Now here I will take m into u. U means what? U is nothing but velocity, right? That is initial velocity. So now here this is initial momentum. This is initial. So that is m into u. And what about this one? This is final momentum. Okay. This is final momentum. Okay. So initial momentum. Now can I say this is m into u is the initial momentum and m into v is the final momentum, right? So now we can write this as, so f is final momentum is m into v minus initial momentum is m into u divided by t. Okay. See here we know the value. Suppose here one object. Okay, I will take its mass as m, and it is moving with initial velocity u. I will apply force. What will happen? Its velocity changes. Say its velocity changes to, I will take v. What about mass? Mass remains the same, right? Now I will ask, what is the initial momentum and final momentum of this object? The initial and final momentum of this object. See, initial momentum here, initial momentum, so that is p equal to m into u, right? So m into u. Then what about final momentum? Final momentum, which is equal to m into v. See, what is moment? What is the definition of momentum? Momentum is, it is a product of velocity, mass and velocity. Here, what is the velocity here? U. So that's why m into u. What is the velocity here? V. Because we don't know values, right? In a mass, you take this number as x, take this number as y. So like that, here I have considered mass of this object as m and its initial velocity as u. So due to the application of force, its velocity changed to v. Okay, its velocity changed to v. So that's why its momentum changed from m into u to m into v. Now, see, in this position, its velocity is v, mass remains the same. So that's why final momentum, that is m into v. Now we can write this change in momentum as m into v minus m into u. So here this momentum changing some time, right? So that's why I have taken time as t. Okay. So this is the concept. What? This is the motion. What it states? The rate of change of momentum is directly proportional to the applied force. Okay. So on this basis, so we will derive the famous equation, that is F is equals to m into a. Okay. So while proving this one, F is equals to ma, so we will use the same concept. Okay. So clear, right? The second statement, what it states, the rate of change of momentum is directly proportional to the applied force. Okay. So due to the application of force, we can change the momentum of an object. Yes. So next directly is F is equals to ma. So this is also very, very important derivation. Okay. Yes. See here. So now we should prove this F is equals to m into a. Okay. So how to start this one? To prove that one, how to start? Here we need force and we need m and a. Okay. So for example, if you want to calculate that force which acts on a body, if you want to calculate that force, so you should multiply mass of that object and its acceleration. A means acceleration. So then you will get the that applied force. But how to derive this one? Already we have studied three equations of motion. Already you have idea how to start the derivations. Okay, so now this one, how to start and how to prove that F is equals to ma. Okay, yes, how to start, please put it in a comment box. I'm waiting for your. I will give 2 minutes time. How to start? Here we need force, mass and acceleration. Yes, just give idea how to start. How to bring that force and how to bring mass and how to bring acceleration. Fast. Quick. Okay, yes, see here. So first consider one object. Okay, first consider one object. Consider one object. I don't know its mass. Okay, I will take the mass of this object. Mass as that as m. Okay, so consider one object and it has mass m. Say it is moving. Okay, just mean that object is moving with the initial velocity u. Okay, so consider one object and its mass is m and moving with initial velocity u. Its initial velocity u. So now just imagine like the force F which acts on this body. Okay, that force which acts on this body. I consider that force as x. Okay, so now consider the force which acts on this body, that as F. Okay, when you apply a force on an object, what will happen? Its velocity changes. Now say its velocity changed from u to v. U to v. U to v. Okay, so your velocity changed from u to v. Why? That is because of the application of force. See here to change velocity from u to v, it will take some time, right? So I will take that time as t. I will take that time as t. So here one object initially it was moving with the initial velocity u. So then due to the application of force, its velocity changed from u to v in a time t. Okay, and we know in a given time here, sometime here its velocity changed. For that one we use one physical quantity. What is that? That is acceleration. Why? Because see, its velocity changes from u to v in a given time, right? So that's why its acceleration, I will take it as a. Okay, see this entire process takes place in a straight line. Why? Because for example, if one object is moving in this direction, if you apply force on in this direction, then its changes in a straight line, right? In this direction only. Okay, yes. Now first see what is the initial momentum? First one, what is the initial momentum of the body? Now momentum of that body, I will take it as p1. P1 means what? Initial momentum. What is the initial momentum? Initial momentum is before the application of force. So that is the p1 equal to m into v, m into u. Right? Momentum means it is a product of mass and velocity. So what is the mass? Mass is m. What is the velocity? That is u. So that's why initial momentum is m into v. Next, what is the final momentum? So final momentum, I'll take it as p2. So final momentum is equals to m into v. Here also same. It is a product of mass and velocity. Okay. So initial momentum is mu and W2 is m into v. Next, what is the next step? Okay, so here we have considered one object, its mass as m and it is moving with initial velocity u and its velocity changed from u to v. That is the application of force in a given time and it has acceleration a. So first we have calculated initial momentum p1, that is m into u, then final momentum p2 equal to m into v. What is the next step? Quick. So now here momentum change, right? Now can I write change in momentum? Okay. So then write change in momentum. Change in momentum. What is that change in momentum? So I'll take that change in momentum is equals to P is equals to P2 minus P1. Change in momentum means what? Final momentum minus initial momentum. Okay. Change in momentum is final momentum minus initial momentum. Next, so P is equals to, what is the final momentum? So here now the change in momentum is P equal to m into v minus u into u. Okay, change in momentum m is equals to v minus u. Now rate of change of momentum, what is that? Rate of change of momentum. Okay, rate of change of momentum, which is equal to, rate means what? Something divided by time. So that's why that is m into v minus u divided by time. Okay, so clear, right? The rate of change of momentum is equals to v minus u divided by time taken. Okay, now just observe here. So consider this one. So v minus u divided by t. So what is that? Okay. So we can write this, the rate of change of momentum is equals to m into a. Here a is equals to v minus u divided by t. So what is that? So velocity changes in a given time. So that is acceleration. Okay. So now we got rate of change of momentum is equal to m into a. Yes, we got m and a. Okay, now we need f. So f is it we need equal to m into a. But here we got the rate of change of momentum is equal to m into a. So next, what is the next step? So now according to, what is that? According to second law of motion. According to second law of motion, what it states? The rate of change of momentum is directly proportional to the applied force. Okay, we can write, see, F is directly proportional to the rate of change of momentum. Okay, so rate of change of momentum. So this is the statement. This is the statement of the second law of motion. Okay, what it states? F is directly proportional to the rate of change of momentum, which means the rate of change of momentum of a body is directly proportional to the applied force. So that is the statement of the second law of motion. So using that second law of statement, so now we can prove F is equals to ma. So now here F is directly proportional to rate of change of momentum. But here we got, right, rate of change of momentum is equals to what? M into a. So now substitute here. So we can write F is directly proportional to m into a. So clear? Okay. So F is directly proportional to rate of change of momentum. A. So now we need F is equals to m into a. So we got F, m and F. So now we should remove this proportionality symbol, right? Yes. How to remove that? In the previous year, we had studied by deriving this same equation, F is equals to ma on the basis of acceleration. So how to remove that one? Okay, see here. So now to do this one here, we should introduce one constant, that is f is equals to k into m into a. Okay, so here what that k represents, that k is the constant of proportionality. That k is the constant of proportionality. So now we should remove this k. How to remove this k? We need f is equal to m into a. So here first we should consider one small unit force. What is that? Unit on a body of mass 1 kg, and it produces acceleration that is 1 meter per second square. At that time we will get f is equals to 1, then a is equals to 1 meter per second square, and mass is equals to 1 kg. Okay, here we should consider one unit force which acts on a body of mass 1 kg, and it will have acceleration is 1 meter per second square. Okay, so now here we got f equal to 1, a equal to 1, f equal to 1. So now substitute these values in this equation. Okay, I will call this equation as and final momentum, that is mv. So later we have calculated change in momentum. Change in momentum means what? Final momentum minus initial momentum. Okay, so then we have written mathematically that as change in momentum p is equals to m into v minus u. So later we have considered the rate of change of momentum. The rate of means what? Something is something divided by time. So here the rate of change of momentum, which is equal to change in momentum in a given time. So that is m into v minus u divided by t. Okay. So according to second law of motion, okay, it states that the rate of change of momentum is directly proportional to the applied force. So that's why f is directly proportional to the rate of change of momentum. So later we got this equation, right? So f is directly proportional to m into a. So to remove this constant of proportionality, so here we have introduced one constant. Here k means what? It is the k is the constant of proportionality. So later we have considered one unit force. Okay, that unit force which acts on a body of mass 1 kg, and it produces acceleration that is 1 meter per second square. Okay, so later we substituted all those f here, m value in this equation, and finally we got f is equals to ma. Okay, so I'll stop here. Tomorrow I will continue the class. So tomorrow also once again I will explain the same derivation, and I will give the notes. Okay, thank you. Thank you.